In this video, we're going to talk about how we can use the graph of a quadratic function to determine what the vertex form is for the original function and how we can write this algebraically. And the idea for this method is we want to write the final form into a vertex form. So just to recap the vertex form of a quadratic function, let's name it f. F of x will be equal to a times x minus h squared plus k over here. A is a leading coefficient, just as we saw in the standard form. We have ax squared plus bx plus c. That a is the same a over here, that leading coefficient. It kind of determines which direction the function opens up and how wide the parabola is going to look like in general. That's a big picture idea for what a does. And for the h and the k values, that's going to be the vertex. And therefore, if you are looking at a function graph, if you can identify the vertex, you should be able to tell the h and k values directly. And that's where we're going to base everything off of. If we look at part A, when we want to write things into the vertex form, we first want to identify what the vertex is over here. And here the vertex is right here. And that's where we want to be a little bit more careful with identifying what the scale is being used. So on the horizontal direction and vertical direction, you can see the scales are exactly the same because the tens on the x-axis and y-axis are at the same distance away from 0. So that's how I can tell they're using the same scale. And also, it's every 5 boxes is equal to 10, so I know every unit I'm going through, it's going to go down by 2 on the left side every time, and similarly on the y direction it's going to go down by 2 every time. And based on this, if we just count the boxes, we have -2, -4 being h and k values over here. So if I know hk is equal to -2, -4 over here, right away I can start writing things in the vertex form. I don't know a yet, so I'm going to leave it as a, and I can have x minus h, which is -2 squared, and plus -4. And just to clean things up a little bit, we can simplify the minus sign and all that, and get f of x should be equal to a times x plus 2 squared and minus 4 over here. And now in order to determine what values our a is equal to, that requires us to choose another point on the graph that's easy to identify over here. And generally you want to pick the point that falls exactly on the point over here. So I think one of the points we can find is going to be this one over here. This point looks like it crosses the intersection of the grids exactly over here. You can alternatively choose some point like this point over here. The mirror image seems like it's also right on the point in this case. And you can also see, I believe we get these 2 points are right on the intersection of the grids as well, and you have some flexibility in terms of which point you want to choose, and just pick whichever one you think is easier to work with overall. But I just want to point out your options right away so you can actually identify the points and kind of know what to look for when you're looking at a graph. So here I see that the graph goes through the origin, so I'm just going to use this point 0, 0. And what that tells me is when I have this function, even though I don't know what a value is, I know that when x is equal to 0, y is also equal to 0. So I can use that information to help us identify things. And just for easier color coding, I'm going to use a green for these 2 coordinates to be plugged in. And that tells me when x is equal to 0, I would just plug 0 into x plus 2 squared minus 4 when that happens, y is also equal to 0. So f of x is also equal to 0. And based on this, we can go ahead and simplify things a little bit. 0 on the left side, we don't need to do much with it. On the right side, we have 0 plus 2, which is 2 squared. So 4a minus 4 in this case. And now if I want to find a, I can just solve the linear equation. Add 4 on both sides, we get 4 equals 4a, and then 1 is equal to a. Therefore, that tells me the leading coefficient a is equal to 1. In other words, we can say f of x is equal to 1 times this whole thing. So it'll be 1 times x plus 2 squared minus 4. So we're just plugging our a values into this part, a over here. And if you want to double check that your function indeed makes sense, you can even use one of the other points that we identified that are easier to read to check whether it does indeed satisfy the function. For example, this point over here, it's 1 unit over, so it's 2. And then on the vertical direction, it's 12 over here. So if you plug 2 into x, we want to check whether y is equal to 12. If we plug 2 in, we get 2 plus 2 is 4. 4 squared is 16. Minus 4 is going to be 12. So you can use that to check this whole process over here. And since this is the first time we checked, we can kind of even write out the steps over here as well. We want to see whether 12 is indeed equal to 2 plus 2 squared minus 4 over here, because this coordinate 2 and 12 are what we identified as the coordinates. And we get 12 is equal to 4 squared, which is 16, minus 4, so 12 is equal to 12. That checks, and that tells me I have the right solution over here. So just knowing that you have the option to check kind of gives you a little bit more confidence when you are going through the problems. You know right away yourself whether something is correct or not. Now looking at the part B, we can use the same approach over here, where I'm just going to name it a different function so it's a little easier to differentiate. So let's say it's g of x, that's equal to a times, again we want to use the vertex form, x minus h squared plus k. Again, we won't know a right away, but we can find h and k first. And in this case, if we look at the vertex, we would see it's right over here. And if we look at the scale on the x and y direction, again they're the same scale because 5 or negative 5 are equal distance away from the origin, both horizontal and vertical axes. And if every 5 boxes is equal to 5, then I know every box I go through is equal to 1 unit. So we get the coordinate is going to be 1, 3. And therefore it tells me the h and k values. So we do x minus h squared plus k. And in this case they're both positive, so we don't have to do much more to simplify it. And once we have this form, again our goal is to find some point that we know on the graph are easy to identify, and they are always going to be the points that falls right on the intersection of the grid lines over here. So for example, I know this would be 1, this would also be 1, and you can alternatively choose this point or this point, and there are more points going down. I think this one over here, this one over here. These are all your candidates. Just choose one though. That's all you need in order to identify it. And in this case, if we want to find out what values we have for a, we're going to pick any random point. Let's say if we choose a point here, going to use the point here, which is corresponding to 3, negative 5 over here, just to show that we can really choose any point for this process. And when y equals negative 5, that's the output. So I want g of x to be equal to -5, and that's equal to a times 3 minus 1 squared plus 3 over here. And to simplify, we get -5 is equal to 3 minus 1 is 2, 2 squared is 4, so 4a plus 3. And generally you won't have super complicated equations to solve either way. It's always going to be a linear equation. And to find a, we can subtract 3 on both sides and get -8 equals 4a. And to get a by itself, we divide 4 and get -2 is equal to a as a result. So that tells me I'm saying g of x is equal to -2 times x minus 1 squared plus 3, because I'm again just plugging -2 into a as a result. And to make sure our answer is correct, again, you can pick any point to check your answers over here. So for example, if I pick the point over here, this would be the point corresponding to 2, 1. We can check and see if we plug 2, 1 into the equation. I would want the output to be equal to 1, but I want to check when we have input being 2 plugged into the proposed vertex form, where I have the input being 2, output being 1, and see whether that checks out. And on the right side, we have 2 minus 1, which is 1, so -2 times 1 will be -2 plus 3. And we do indeed have 1 equals 1, so we know that our proposed vertex form is indeed correct, because the other point we know is on the graph is also going to satisfy this equation. And that's how we go about finding the vertex form from a given graph.